Welcome students, I am Dr. Fischer. I welcome you all in my channel Chemistry, the Mystery of Molecules. So today we will discuss another reaction, important main reaction for the preparation of 5-member heterocyclic compound, that is indole. So this video belongs to the lecture series about the 5-member heterocyclic preparation. So I suggest you please visit other videos also if you haven't. So what we are going to discuss today? We are going to discuss today about the preparation of indole. First of all, the basic concept, means today's talk will cover these points like basic concept, reaction mechanism, proof of mechanism, role of ortho-para substituents and electron releasing, electron donating group, proof of mechanism, for example unsaturated intermediate, nitrogen leveling study, those things, and finally we will discuss example to cover this topic completely. So a lot of chemistry to be learned. So let's start. So as you can see, this is phenyl hydrazine. This is reacting with carbonyl, ultimately producing this. And in this case, actually H plus is used or Lewis acid used. Instead of that, I'll explain, you understand. During the first step you can use mild base also, but the last step is it is essential to use a particular acid or Lewis acid because the aromatization, this CC bonds formation, this thing I'll explain during the mechanistic study. So this is, and this is phenyl hydrazine. What is the easy way to prepare phenyl hydrazine? The easy way is diazonium salt react with sulfur dioxide. Sulfur dioxide will reduce it into the hydrazine derivative. As you can see, this is hydrazine, this is a 2 lone pair. So there is a lone pair repulsion which is considered as alpha effect. So because of this alpha effect, this is more nucleophilic. Consequently, this sheet-based condensation reaction between these attacks and opens up, followed by, so this is NH, this is NH2, this OH. Actually better to write this as NH because this will be O minus, after that it will abstract the proton from this. So this is OH. This is CH2R1 and this is R. Please careful about R and R1 position, you will understand why. So this, and next step what's happened? This water elimination to form this sheet base, means imine. Means this hydrogen, this oxygen will remove as water. So minus water. So this is, now the question, we have achieved this preparation of this hydrazone. In next step what happens? Let me draw the hydrazone little better way. Okay, just this is R, this is CH2R. So what can happen in next step? Next step, this hydrazone can tautomerize. Okay, it can tautomerize to what? For get what? This is NH, this is double bond N. So tautomerization between this proton and this. So the double bond will be shifted from this. So this you can think like that. So this is the NH, this is the double bond, this is the R, and this is R, and this is CH2, this is R, and this from CH2 this proton is gone, so this is R1. Don't be confused. This is the mechanism of the process. So I think I should write it a little better way. This is R1. Fine. So this, and now what happens? In this case, acid is essential. Okay. What happens in presence of acid? First, this protonates. So this protonates into NH2 plus, and next step it's a 3,3 sigma-stropic shift. 3,3 sigma-stropic shift. Is it working? Yes. So this 3,3 sigma-stropic shift results, how this reaction happening? See, please follow this carefully. It provides here, it goes here, it comes here, in this way. Okay, you can do the reverse arrow moving also, but that's also right. But no, I believe that is not right. That is not right. Or better to say, you can do this here, this go, this possible, another one also. Okay. So this, so ultimately what is the product? So here one bond formation, there is one proton. Here there is a double bond NH. This bond is broken, see this bond. So double bond NH2 plus, nitrogen has the formal positive charge. This has a single bond, R1 is here and R is here. Got it? Okay. So this is. In next step what happens? That this proton is abstracted in order to get the aromaticity back. So it abstracted, it comes, it opens up. So what it resulted? It resulted the gaining of aromaticity. Okay. So in this way aromaticity is back. Fine. This is NH2. So in next step what happens? There is intramolecular carbonyl addition, actually imine addition. This is actually a protonated imine. So what happened? This goes and attack here and it opens up. So what is the consequence? The consequence is, this is the benzene, this, see, this is attacking to this carbon. So this is 1, 2, 3, 4, 5. So 5 member ring formation. So let's draw the 5 member ring with nitrogen. Fine. This NH2, let's draw it NH2. After attack, it will become positive. Fine. And it will open up. So NH2 became neutral. This is the NH2. And this NH2 is attached to R. So R is here and R1 is here. Okay. Now see, this is like a amine addition to the carbonyl compound. So this is in next step what happens? This removes one hydrogen in order to be neutral, and that hydrogen is taken by this ammonia to become NH3 plus. Now this is a good leaving group. So what happens? This, it comes back. Actually medium is acidic, so don't be confused. And not only acidic, if you use Lewis acid like zinc chloride, then also possible. Okay, similar type of mechanism is followed. So what happens? So it leaves means this is a double bond formation. Fine. So this is a nitrogen is having the positive charge. Now see, there is another double bond. Now you may ask that, sir, why this will shift? Because of to gain aromaticity. So it will be abstracted, it will come and it will open. So what is the product? The product is, this side is phenyl, this is NH, this is R1 and this is R. Okay, so this is the overall mechanism of this process. Now you can see this mechanism involves few steps. What are the steps? First of all, seed base formation. What I have explained is not difficult because of this lone pair alpha effect. Fine. In next step, 3,3 sigmatropic shift. In this case, it is observed that if you have ortho and para substitution, okay. For example, if you have one para and one ortho, then this position is vacant. Then selectively reaction will happen in this position. Careful. Second, first point is selectivity. Second point is electron donating or withdrawing group. It's observed that if you have electron releasing group or electron donating group, reaction rate increases, it happens easily. Electron withdrawing group, it's difficult. Why? See, actually, if you increase the electron density in this ring, actually this ring electron is going somewhere and doing the reaction. So if you increase the electron content in this ring, reaction becomes easier. Compared to that, if electron withdrawing group is present, then that's difficult. So that's why electron donating group increases the rate, whereas electron withdrawing group reduces the rate of this reaction. Okay. So we have understood this is orthoselective and second is electron donating group enhanced thing. Now we will discuss about the isolation of intermediates to give you a better idea about the overall process. Okay, so this 4 experiment through we can prove the mechanism. Okay, before that I forget to give one thing. For example, if you take this indole, so this is NH in, and this is one side is methyl and one side is ethyl. Okay, then there is a chance of two product formation. What are these two products? These two products are, one is from this side, means one is tautomerization with this side. So what it will result? It will result in this NH. This is CH3 because this position and this carbon will form the double bond. So this nitrogen attached carbon should be CH3 and there will be another CH3. One. This is the path A, means star. But if you think the other path means this, if the enol forms in this way, means CH2 in this way, if this okay, better to say this NH, this enamine forms in this way, then what it will result? It will result, see, the nitrogen adjacent carbon contains ethyl, so the product will be, this is the NH, this is C2H5. This. So there are two chances also. For unsubstituted ketone, there are two chances two product can form, and actually what will be produced, it depends on the material and reaction condition. For example, what acid we are using, temperature, etc. conditions. Okay, so let's discuss about this. So this is the isolation of intermediates. So what happens if you do this reaction? If you want to do this reaction in terms of acetic anhydride, for example, if you use acetic anhydride, there is a chance a slight amount of acid is there. So what is expected? That they will undergo normal reaction. Instead of that, what is obtained? The intermediate is isolated. What is intermediate? NCOCH3 means AC. Similarly, this COCH3, this is because it is converted into the NH imine. So this is the CH3 and this is the CH3. Okay, so this is isolated. So it's diacetylated product. So this is proof number 1. Fine. Now see this example. See what they have done, they have initially taken methyl substituted in both cases. And what they have obtained under 110 degrees centigrade in terms of decalinous solvent, they have obtained this carbazole, N-methyl carbazole derivative along with methylamine. Previously we have observed during the reaction ammonia was released. So if it is substituted, then it means methylamine is released. How this is happening? So in this case, under this condition, what happens is C3 sigmatropic shift. It comes here, it goes here, and it goes. So what it produces? So let me clean this part. So what it produces? It produces this is NCH3 minus, this is double bond NCH3. Along with that, here there is a 6-member ring. Fine. This. Now the question is, okay, better to say, there should be this in double bond. Okay. So this. Now the question is, there is one hydrogen. So this hydrogen is abstracted by this nitrogen, which can act as a base in order to gain the aromaticity. So this opens. So it results in this, and here this aromaticity is gained. Fine. Now next step, what happens? It attacks, because one nitrogen have abstracted the proton to gain aromaticity, so that is, it is NH plus. See, there is no acid base is given, that's why I am balancing the acid, where it's coming, where it's going. So this, and ultimately So it opens up. Fine. Means it opens up means there is a bond formation with this nitrogen is a plus charge. Then there is NHCH3. Okay. Similarly, it will get another proton from the molecule, and ultimately what it will result. Actually, I think I made mistake. Okay, I made mistake, because when it will come, it is minus. So that minus is actually attack, not the plus. What do I mean? See, after this, what is produced? I get confusing. So after this sigmatropic shift, this is a carbon-carbon bond with this proton. This is NCH3. This is a cyclohexane ring, double bond, NCH3. Fine. Now what happens when aromaticity is gained? This, so now N becomes minus. Okay. So this way, and second there is another nitrogen. So this can abstract another proton. So actually this minus is attacking. So this, and in next step it will push, it will leave. Okay. So ultimately there is a double bond formation in this position. Then there is a tautomerization. This just I have explained. So in this way this carbazole is formed. Why I have given? So this is another heterocyclic moiety which we will discuss later on, carbazole. And along with that, see CH3NH2. So what it is releasing, CH3NH minus, which abstracting proton became CH3NH2 plus. Okay. So in this way this is producing. Now the another type of experiment, that is nitrogen leveling experiment. So in such experiment, the leveling isotopes are used. In this case used is nitrogen 50. Okay. So this thing you can detect specially, but keep one thing clear in mind, how to prepare those things. See, this is nitrogen. So during the diazotization, what do? We take aniline and react this with sodium nitrate. So aniline part nitrogen should be N15. But if we want to prepare this, then aniline normal, sodium nitrite, NO2 should be N15. In this way you can prepare. So if you hear this, what is obtaining? This N15 is coming here. What does it mean? That this is actually attacking to this carbonyl and producing this. But if you take this, actually what is obtained? So this is NH, this is PH, this is CH3. Sorry, not CH3. There should be hydrogen, because this enum information. So this, along with that, what it's producing? Ammonia with N15. Okay. So what does it indicate? That reaction follows this type of path. This is a very solid proof. Okay. And another solid proof is that if you take a cross combination substrate. What do I mean? Cross combination substrate. I guess this is PH. This is CH3. So in this case, what we are getting, this is, and see, methyl is remaining. So it also proves, see here both are not similar. In previous experiment that is little difficult because it's a leveling experiment. Where do I get N15? But you can prepare easily this thing and do. And if it is observed that this leveling remains, which also supports the proof for this reaction. Okay, now discuss example. Okay. So let's look at this example, one example quickly. A clever MCQ could be constructed. See this example, what is happening in terms of H plus and heat. In the exam, it could be given as a question mark. What is produced in this reaction? And 4 options given. For example, first option is A, means this product. Second is this product, means C, methyl position is different. Third is phenyl position is different. And fourth is phenyl methyl both is different. So one MCQ could be constructed very easily with these options. So I have given you because it may be helpful for your CSI and NET exam. Okay. So let's start discuss the problem. See, this is a unique example because as I told during the mechanism study that one ortho position need to be vacant. But see, surprisingly here both ortho position are blocked with this methyl group. So reaction will happen. Actually, it's happening. How this is happening? That is the question. Okay. It's a very interesting example. So What is the steps? For example, it CH3 will undergo enamine formation with this, and this is NH. Second step, it will be NH plus because acid is there, hydrazine. Fine. In next step, 3,3 sigmatropic shift. How? See, it can push here, it can push here. This is another arrow movement, so both possible. That's the proof. This. So what will be the product? The product will look like this is CH3. This is CH3. Sorry, this bond will not be there. This double bond NH. NH2 plus with double bond, one is pH, one is CH2 attached with this. Okay, this. So now what can happen? So what can happen that along with this plus, it can proton could be exchanged to this plus also. Fine. So what is the next step? This can push and it can open. So what is the product in this case? So plus charge is here. This is, I'm giving you, showing you stepwise. This next step, what can happen? This double bond can come here. So what will be the canonical form? Canonical form will be this. So this plus charge is here, and this is an interesting thing. See, here methyl is there adjacent to the plus charge. So what expected that this methyl can migrate here, and what is the driving force? You can see little later. So what it can produce? So this is the hydrogen, this is the methyl. So this is the methyl, NHPH, and this is NH2. Fine, plus charge is here. So what is expected that in next stage this proton could be abstracted and it can come here. So that is the reason. Means in order to adjust the aromaticity. In previous all cases this position is vacant, means there is a proton, but right now no proton. Seen, so consequently what it will result? It will result in this formation. And next step, what is expected? In next step, as think that again this will be called NH2 plus, then this NH2 will attack and follow the similar process to ultimately undergo this. So the interesting point or key step of this plus charge will come through this ring and this methyl will migrate. Okay, so this is the overall discussion about. So this is the this is the end of this discussion. I think this video may be useful. So what we learned today? We have learned today about details about Fischer Indole synthesis, basic concept, reaction mechanism, and most importantly proof of concept, proof of reaction mechanism, and finally this example. Okay, so I think this video may be useful for you. If it is, please help me to grow my channel. First of all, subscribe my channel Chemistry the Mystery of Molecule, and please press the bell icon to get the notification of every single video I upload. Secondly, share this video among your friends such that many people could be benefited from my effort. And lastly, that most importantly, please like and make some good comment. And if you think you need some improvement in my teaching, please mention that also. So till now, stay happy, stay blessed. See you in my next video.